So for part 3, or part C, we want to find the pH after 30 mils of NaOH was added. At this point, equal moles of NaOH and HCl have reacted, okay, because I started with 30 mils of 0.5 molar HCl, and I've now added 30 mils of 0.5 molar NaOH. So this is, I do not know its equal moles just because the volumes are equal. I know it's equal moles because the volumes are equal and the concentrations are equal. So if the concentrations have been different, just because the volumes are the same, we wouldn't necessarily know that we've reached the equivalence point. I only know that because both the volume and the concentrations were equal. If the concentrations were not equal, I would go through like I did in part B, and I will do in part D, where I make the ice table to find the concentrations, well, the moles of H plus and OH minus, the concentrations of them, and then the pH, okay? So again, I only know it's equal moles because both the volume and the concentrations were equal. So at that point, since both of those are exactly equal, all the H plus ions in the solution have reacted with all the OH minus ions in the solution to create water. So there's no H plus left and there's no OH minus left, which means that the pH is equal to 7. You can also think if they're all making water, pH of water is 7. And this would be true for the equivalence point of all strong acid, strong base titrations. Not necessarily true if we have a weak acid or a weak base reacting. The pH would not necessarily be exactly equal to 7 at this point. For part D, we want to find the pH after 45 mils of titrant is added. So we're again going to find the initial moles of HCl in the solution, which is the same because we still are starting with 30 milliliters, and the concentration is still 0.5 molar. So we find that we still start with 0.015 moles of HCl. Then I'm going to find the moles of NaOH added to the solution by multiplying my volume and my concentration. This time my volume is 45 milliliters, which is 0.045 liters, times again that 0.5 moles per liter. So I find that I have 0.023 moles of NaOH. Then I'm going to set up an ice table to find how many are left when this reaction reaches equilibrium. So again, my initial is 0.1015 and 0.023 moles for H plus and OH minus. My change this time, OH minus is present in excess. My limiting reactant is H plus. So my change is going to be determined by H plus. So I'm going to have minus 0.015 as my change. Then in the final, at equilibrium, I'll have 0 moles of H plus and 0.008 moles of OH minus. Now, if I had made a mistake and been like, oh, I always subtract the moles of OH from the solution or something like that, I would have gotten a negative number of moles. Remember, you can't have a negative number of moles of something. It's like you can't really have negative cookies unless you consider like debt of cookies, which we don't because we're not 5. So if you had done that, you would have gone back and said, okay, what did I do wrong in the change? And then maybe you would have tried to do the minus 0.015 instead, and then found that you get positive numbers, which is what you want. So at this point, the equivalence point has been passed. So up to the equivalence point, we're going from a very low pH to a pH of 7. And then past the equivalence point, we're going from a pH of 7 to a pH of possibly 14 if we're incredibly basic. So at that point, once we reach the equivalence point and go past it, we can't just find the concentration of H plus and find the pH that way. We have to find the pOH and then subtract to find the pH. So to find the pOH, I first have to find the concentration of OH minus. Just like for pH, I have to find the concentration of H plus. So I'm going to take my moles of OH minus and divide by my new volume. My volume, I started with 30 mils of the analyte. I added 45 mils of the titrant, so my new volume is now 0.075 liters. I take 0.008 moles divided by that 0.075 liters, and I find that I have a concentration of OH minus of 0.1 molar. So now POH is going to be the negative log of the concentration of OH minus. So negative log of 0.1 is equal to 1. And then to find pH from the POH, I just subtract from 14. So 14 minus the PaOH, 14 minus 1, is equal to 13. So I know my pH of the solution is 13. So now we have a very basic solution because we went past that equivalence point. Okay, so that is the quick little overview of titrations in case that shows up on the AP exam, just so you kind of know what to consider, what a titration looks like, and things like that. Okay, have a wonderful day.